Hey there, Seahawks. It's Miss Adams, and in this video, we're going to talk about finding critical values. All right, so the critical value is a factor used to compute the margin of error as shown in the equation below. So our margin of error is our critical value times the standard deviation of the statistic. So our error is equal to z star times the standard error of p hat when I'm working with proportions. So using Z table, so you'll have a table that looks something like this. If you want to estimate the proportion of successes at a 94% confidence level, what critical value do you need to use? All right, so if I'm using a 94% confidence level, that means I'm accounting for 94% of the data in the middle. All right, well, that leaves me with 3% on either side, okay, because it's out of 100%, so 100 minus 94 divided by 2, because I have some on both sides, gives me 3%. All right, so I'm really looking at 97%, because when you're using the table or the calculator, you're always doing the value at or below that point. So I have to include the one tail and the 94%. So I'm looking for, in this table, where I could find 97. All right, so I got 0.9699. That's pretty close. So I'm going to go ahead and go over, across, and to 1.8. And then I'm also going to go up to 0.08. And I could estimate that Z star is approximately 1.88. So I'm combining those two pieces and putting it together. 1.8, 0.08. When I put those together, I get 1.88. All right. I could also use the calculator to solve this. All right. In this one example, we're going to use the graphing calculator. So using the calculator, you will still need to figure out the area to the left of the critical value cutoff and use the inverse norm feature under the distribution menu. So you're going to hit second vars, which is your distributions. Then you're going to go to inverse norm, and you're going to enter the area and leave the mean as 0 and the standard deviation as 1. Okay, it's because you're getting the standardized values. So find the Z star value for a 92% confidence interval. So real quick, we're going to draw a picture. We have our normal model with a mean of 0 and a standard deviation of 1. We have 92% in the middle. That leaves us with 4% on either side. So I'm going to go, the 4% plus the 92% gives us 96%. So I'm going to do inverse norm in my calculator, second vars, inverse norm. Area would be 0.96, mean would be 0, standard deviation would be 1. Okay, so quickly I'm going to walk you through what this would look like actually typing it into your calculator. So second vars, inverse norm is option 3. Area was the 92% in the middle plus the 4% on the left side, which gives us 0.96. Mean is 0, standard deviation is 1. Paste, enter, and we get our answer of 1.75. All right. So for our other one, find the ZC. That's another way of putting your critical value, so your critical Z score, depending on the notation that they give you, for a 97% confidence level. All right, so we have 97% in the middle. That's going to leave us with 1.5% on either side. So my area would be 98.5, because 1.5 plus 97 is 98.5. Okay, and that gives us 2.17. So again, it's second vars. Inverse norm is option 3. We would put in here 0.985. Mean of 0, standard deviation of 1. Enter, enter. We get 2.17. All right, so the most commonly used critical values, you're probably going to want to just memorize so that you're not having to do this calculation every time. Typically, we're going to be working with 90, 95, and 99%. So the critical value for 90% is 1.645, 95% is 1.960, and 99% is 2.576. And I like them to be to 3 decimal places. All right, go Seahawks.